Solve the log equation symbolically. I have three equations here. These are log equations because the variable is inside the log, and that's what makes it a log equation. And in order to get that variable out, we need to combine the logs into one single log and then convert it to exponential form. So here we have a single log, but we have this stuff that we need to move over to the other side. So I'm going to subtract 42 from both sides, and I get 4 log of x equals negative 12. Then I'm going to divide both sides by 4, and I get log of x equals negative 3. Now I need to convert this into exponential form. The base is understood to be 10 because this is the common log. And the log is the exponent, the base is on the bottom. So we're going to have x equal to 10 to the power of minus 3. All right, remember we're just converting a log equation into an exponential form. Okay, so that just means that we have x equal to 0.001. Here we have two logs that we need to combine into a single log. The base is understood to be e, and so this is the natural log, so we can go ahead and combine those into the natural log of x times x to the 6. That's because the sum of the logs is the log of the product. So, and that's equal to 7. And then this becomes the natural log of x to the 7th equals 7. The base is e. So e, then the log is the exponent. So e to the 7th is equal to x to the 7th. And so then x must be equal to e. You just take the 7th root of both sides. Okay, now here, again, we have several logs. We need to group them all together and combine them. So we're going to subtract 4 log of x from both sides so that we can get one single log. And we get log of x to the 6 minus 4 log of x is equal to 3. Now I need to combine these, but first I got to deal with this negative 4. It's in the way right now. So I'm going to make that an exponent. So this becomes log x to the 6 minus log x to the 4th power equals 3. Now I can go ahead and combine these. This is the difference of logs, so that's the log of the quotient. So we get log of x to the 6th divided by x to the 4th equals 3. And that's log of x squared is equal to 3. The base is 10 because this is the common log. So the base is on the bottom and the log is the exponent. So there we have 10 cubed, right? And that is equal to x squared. And we're going to have to take the square root of both sides to get that x is plus or minus the square root of 1,000. Now be careful. In this particular example, we have two answers, and it turns out that one of them is not correct. And that's because with logs, when you solve the log equation, okay, make a big note in your notes on this. When you solve the log equation, you need to check that your answers are going to work in your equation, because remember, the domain of the log is all positive numbers. So here I'm trying to take log of x, 0.001 is x, that's positive, we're good. Same here, I'm taking log of x. Now, this even exponent is okay, and you can put a negative number there, but this was going to throw you off. If you have a negative, that's not going to work. X cannot be negative. But that's okay because e is positive. In fact, e is approximately equal to 2.72. Okay, so that's positive, that's fine. Here is where we run into problems. We can plug in the square root of 1,000. Okay, the square root of 1,000 is just simply 31.62. Okay, But negative 31.62 is not gonna work right here. You can't take the log of a negative number. So you gotta throw out that answer. So on these log equations, always check your answers. So we're gonna throw out the negative and just keep the positive one.